Hello everyone, welcome to this lecture video. In this lecture video, we're going to discuss about the memory management in the operating system. In the unit 3, we're going to cover the storage management. In this today's video, having the memory management topic, first we have to discuss what is memory management or how the memory management needed for the operating system. So, what is memory management and why it is needed in the operating system? So memory management is a functionality of operating system which handles manage primary memory and moves a process back and forth between the main memory and disk during the execution. So it is the most important function of an operating system that manages a primary memory, and also it helps the process to move back and forward between the main memory and execution of the disk. So for example, in the operating system, any task we are do process we are doing, so it will be stored in the main memory, then it will be transferred to the secondary memory. So from the main memory to the process, from OS, any process happens or doing in the operating system, it will be stored to the main memory. The main memory will be transferred to the secondary memory. It is the most important function that why we call as memory management in the operating system. So it helps us OS to keep the track of every memory location, irrespective of whether it is allocated for some other process or it remains free. So moreover, to increase performance, several processes are executed simultaneously. For this, we must keep several processes in the main memory. So it is even more important to manage them effectively. So for example, we have to retrieve some data from the secondary memory. It will first transfer to the main memory. So for this, we have to several processes in the main memory, process P1, P2 in the memory. So it is even more important to manage them effectively. So here, why we use memory management? Here are the reasons for using memory management. It allows the to check how much memory needs to be allocated to process the decide which process should get memory at a time. So where the tracks whenever inventory gets freed or unallocated, according to it, it will update the status. So it allocate the space to application routines. So also it also makes sure that these applications do not interfere with each other. So it helps the product different process from each other. So it places the program in your memory so that memory is utilized to its full extent. So why we are using the memory management? Here are the reasons for using the memory management. So main reason is to allocate the space to application routines. So here, memory management have the major role playing in the operating system, from retrieving the data whenever need the different kinds of process in the operating system, temporary storage of cache memory and other things will be plays a important vital role for the operating system here. So here are the reasons for using the memory management. So it plays the programs in a memory, so then that memory it also utilized, so it's a full extent. So then partition allocation. So memory is divided into different blocks or partitions. So memory can be divided into different blocks, different block 1, block 2 or blocks or partitions. So each process allocated according to the requirement. Partition allocation is an ideal method to avoid integral fragmentation. So below the first various partition allocation schemes are here: first fit, best fit, and worst fit, and next fit. So in this type, the partition is allocated which is the first sufficient block from the beginning of the main memory. So best fit is allocates process to the partition that is first smallest partition among the free partitions. Worst fit is allocates the process to the partition which is the largest sufficiently freely available partition in the main memory. So next fit, we having the more similar to the first fit, but the first fit says the first sufficient partition from the last allocation point. It allows you to check how many memory needs to be allocated to the process that decide which process should get more memory at a what time. So partition allocation can be happens like these kind of things. Memory management techniques we're having. single contiguous allocation, partition allocation, and page memory management and segment memory management. So single contiguous allocation is the easiest memory management technique. In this method, all types of computer memory except a small partition which is reserved for the operating system available only for of an application. Example, MS-DOS and embedded OS. So partition allocation divides the primary memory into various memory partition, which is mostly contiguous areas of memory. Even every partition stores all the information for a specific task or job. This method consists of alerting a partition to a job when it starts and allocated when it needs. So page memory management, this method divides the computer memory into a fixed size and known as the page frames. So memory management techniques, single contiguous allocation, partition allocation, page memory management, and segment memory management. I hope in this lecture video we have seen what is memory management and why, what is the need of use of memory management in the operating system, and we started with the memory management techniques in this video. Remaining things we can see in the next video. Thanks for watching. Thank you.